Hello again, doing a little bit of video today on caster, toe, Kingpin inclination, scrub radius, Ackermann and Camber, which are all things you might consider when you're making a cycle cart. We're looking at a GN one now, obviously, or GN inspired one. There are things that are not right on it for those things that I've just mentioned. I'll go into that in a minute. But they're not right for a reason, and I'll go into that also. I'm going to do this in what I think is order of importance when it comes to stability in a cycle cart. And they all might have some effect, but some will have less effect, especially seeing as we run wheels and tyres that have got a very small contact patch, and our tyres are not flat on the bottom. They are generally round in profile from motorcycles, so things may be a bit more important in some areas than others. The first thing I'm going to talk about is caster. Caster is the angle that the Kingpin is inclined in the vertical plane as you look at it from this angle. And in this case, I've got mine set to 8 degrees. Now, if you buy a Gemini axle, that's already set to 6 degrees. You can add or detract from that by putting mounts on the springs at a different angle. 6 degrees on the Gemini axle seems to work well for everybody. Some people alter it and add a bit more. On the GN axle, people tend to go between 8 and I've seen somebody go as high as 12 degrees on a GN style axle. What does it do? Well, it's for high speed stability. It stops the system getting into feedback and getting a wobble on when you're going quickly, because it tends to self-center and settle at speed. I had issues with this on my three-wheeler when I first set that up, and I took it down a runway, first event I'd ever been to, hit 35 mile an hour, and the thing was just in a tank slapper. I had to back off on the pedal, otherwise I would have just binned it. It would have turned over on the runway. So I got home and started playing with angles, moved things around a bit, and also added the next thing, a little bit more toe in, and it settled down lovely, and now it will go 45 miles an hour without a twitch in a straight line. Obviously it's a three-wheeler, so it'd probably fall over if I went round a corner, but that's what a three-wheeler does. Part of the fun. Okay, so the next thing we're going to look at is toe in. So toe in is, or toe, is how parallel the wheels are to each other. Toe in, the fronts of the wheels will be nearer together slightly than the rear of the wheel, and I usually measure that at axle height. So on a rear wheel drive car, toe in is usually preferable. On the cycle carts that I've got, I found that about 3 millimeters of toe in is all that's necessary. You don't need to go beyond that. Why do you need toe in? Again, it's a stability thing. If you imagine stability under braking and stability under acceleration, if you imagine a skier going downhill, they will have toe in on their skis slightly, unless they're very, very good and they can parallel ski. Even parallel skiing, they will have a little bit of toe in there. But when you first learn to ski, the snow plough is what keeps you stable going down a hill. Some front wheel drive cars are toe out. Most of our cars, cycle carts, are rear wheel drive. There are a couple in America now that are going on to front wheel drive, but it's a very, very complex thing to get in a cycle cart. So that's toe in. So the measurement across the front axle line between those two rims, when I set the whole thing up to weld, I set that at 3 mil narrower than the rear of it. Easy to measure when it's naked like that. Okay, so down the list of importance, kingpin inclination. Kingpin inclination is the angle the kingpin makes to the vertical in this plane. And if you project down, you can see that that will come to a point about there, which is just to the inside of where the tyre is going to be. The tyre is another 2 inch down from the rim. So where my finger is, you can see it's not centre line, it's just to the inside of the vehicle. Now on rear wheel drive cars, that's where it usually should land, because that creates, here's another angle, the scrub radius. So when that wheel turns in a plane, there will be a slight intersect between where the tyre's touching and where that point is, and the radius between those 2 points is the scrub radius. Again, it's another thing that can help with bump steer and brake steer. If it's too big, you're going to get it, but it reduces tyre slip. Now, rear wheel drive cars handle better with a little bit of that, but not a lot. But again, I don't think that's important in the CycleKart. I think you could get away without that. So provided you've got your caster and your towing right, those are the two biggies. After that, if you've designed your suspension, wheel setup, wheel alignment with kingpin inclination, bully for you. Again, the Gemini ones you buy, they've got 15 degrees of that, and that works out pretty well, and anybody who drives one of those is quite happy with it. So we've done scrub radius, we've done kingpin inclination. Ackermann angle, again we're moving down in importance. I've seen people run with very little Ackermann and it doesn't seem to make that much difference to the handling of a CycleKart. A little bit, not a lot. In extreme cases, if you've got a Formula 1 car for instance, and you're doing a really fast circuit, fast laps, fast corners, really not much turning into the corners, you're just going around, then you actually need negative Ackermann. It goes the other way, and that will turn the outside wheel in a little bit more, and because your weight's on that wheel as you're going around the corner, you're going to turn in better, but your steering is going to be really heavy. So standard road cars are usually set up with Ackermann. Now if you look down the steering arms there, you will see I've got them lined in, there we go, with a white pipe going backwards and try and get a higher view. There you go. And that white pipe, if you continue its line through, it will, if I had two of those, one on either side, it would join somewhere just in front of the rear axle. Pure Ackermann would be it joining exactly on that rear axle, so that when you turn the front wheels, I'll stand back to do this, you'll see the wheel on the outside of the curb turns less than the wheel on the inside, and that's mainly because if you look at it on plan, the inside wheel is performing a shorter radius than the outside wheel and therefore doesn't need as much turning angle. This makes it quite easy to manoeuvre and predictable in sharp, relatively slow speed corners. With CycleKarts, those are what we do. So as most road cars are set up that way, most CycleKarts are set up that way. And is it important? Well, it's down the list of importance. What does it do for you? Reduces your tyre wear, because your tyres aren't fighting against the road by going at radiuses that they're not travelling. And pretty much that's about all you really need to consider, I think, in a CycleKart for Ackermann. The last thing is something I've got wrong on this CycleKart, because if it was a GN, it would have camber. Now for GN it would have positive camber, which means the wheels, as you look at them from this direction, would not be vertical. They would be leaning out at the top on both sides, so that the bottoms of the wheel on the contact points would follow the camber of a road, which is always humpy in the middle. But because Kingpin inclination in this is 15 degrees and the contact point for the scrub radius is about right, if I tilted those wheels down at an angle, I would be putting the scrub radius the wrong side of the wheel for a rear wheel drive car. So I opted to keep them vertical. Now, if you have a look down the alignment between the front and the rear wheels, you can see that they're pretty much the same. I got the wheel slightly out of line there. There we go. Everything's vertical in there, so I'm running 0 degrees of camber, which isn't traditional for a GN, but is it important for a CycleKart? Think of our tyre profile, think of the contact point, probably the least important thing I've talked about so far. So out of interest of getting the Kingpin inclination right and the scrub point right, I've sacrificed the looks of the car for a GN so that it looks not quite right for the front end of a GN, but it'll probably handle better. Anyway, that's it for today. I'll talk about the steering mechanisms and what affects the steering geometry on the mechanisms in the next video.